Well, let me continue to talk about polymorphism. Let me skip the next few pages. So let's go to sorting. Okay, sorting. Sorting is a process of arranging a list of items in a particular order. For example, I give you some numbers. The numbers are messy. They are not ordered. And then you use an algorithm to sort the numbers by ascending order or descending order. The sorting process is based on specific criteria. Sort test scores in ascending numeric order. Sort a list of people alphabetically by last name. There are many algorithms. The efficiency are different. We will examine two specific algorithms. One is selection sort. Second one is insertion sort. Selection sort. The strategy is select the value and put it in the final place in the list. Repeat for all other values. In particular, if you have a list of numbers, the first one you need to put the smallest number in the first position. So you find the smallest number and put it in the list. You need to switch it with the value in the first position. And then you find the next smallest number in the list, and then you put the value in the second position. When you put that one in the second position, you need to switch the position. Repeat until all values are in their proper place. Let's see an example of selection sorting. There are some numbers 3, 9, 6, 1, and 2. They are not ordered. We want to use an approach to sort the numbers. The numbers are by ascending order. So the smallest one should be in the first place, and then the second smallest one should be in the second place, and then the third smallest one should be in the third place. So we scan the numbers, and then we find the smallest number is 1. So 1 should be in the first place, but 3 is in the place. So we switch 1 and 3. So 1 is in the correct place. And then from the second place to the last, we need to find the smallest number that is the second smallest number of all the numbers, and put the number in the second place. We find 2 is the smallest number of the leftover, so we switch 2 with 9. And then we find, so from the leftover 6, 3, and 9, 6, 3, and 9, we find 3. We find 3 is the smallest one, so 3 should be in the third place, but the third place now is 6, so we switch 6 and 3. And then the leftover is 6 and 9. The smallest number is 6. 6 is in the place. So at last, the order is 1, 2, 3, 6, and 9. So this is selection order. In your program, if you want to swap two values, normally you use a third variable to save the temporary value. If you want to switch two values, for example, first and second, if you want to swap two variables, for example, first and second, but you use first equals second, second equals first, that's wrong. For example, if first is 1, second is 2. When you assign second to first, and then first is 2. And then you assign first to second, second is 2. So both second and first are 2. So if you want to swap two values, normally you use a temporary variable. You assign first to temp, and then you assign second to first, and then you assign temp to second. So this temp is the initial value of first. If you just want to use the first and the second, but you don't want to use the temporary value temp to swap two values, you can implement by just two values. So you have some approach to do that. To use only two variables, don't use the third variable to swap two values is a hard interview question. So many students apply for a job, and then in the interview, they are asked to answer a question. Okay, polymorphism in sorting. If a class implements a comparable interface, it's defined a compare to methods to determine the relative order of its object. So we can use a polymorphism to develop a generic sort for any set of comparable objects. The sorting method accepts as a parameter an array of comparable objects. That way, one method can be used to sort an array of people or a book or whatever. You learned the algorithm of selection sorting. Next one, let's see the example of selection sorting. The example is to sort the contacts of phone numbers. So let's go to Dr. Java. First one, you see the class contact. Contact implements comparable. So what's the meaning of this? This means if a class implements comparable, the objects of the class are comparable. So you can compare the objects of the class. For example, the objects of the names of people, and then you can compare the names. The objects of something about numbers, you can compare the numbers. So implement comparable means when you create objects from the class, the objects are comparable. You can compare the objects. Contact has three fields: first name, last name, and phone. This is the constructor of contact. ToString. ToString return last name, first name, and phone. Equals. Okay, equals. This one is to return true or false. So equals is to compare two items. If they are equal, and then return true, otherwise return false. Compare to. This one is to compare the current string with another string and return integer. So the integer is the difference of the different characters for ASCII code. And let's see example. String str1 is assigned with apple. String 2 is banana. String 3 is grape. If you call string 3 dot compare to string 2, so string 3 compare to string 2, and then you compare G and B. G and B are different. The ASCII code of G is bigger than B, and the difference is 5. So result 2 is 5. If you use results equals string 1 compare string 2. So string 1 is apple, compared to string 2 is banana, so compare A and B, they are different. And then the result is -1. So the number 5 and -1 are from the ASCII code. If apple compare with another string, the first one is A, second one is B, is P, third one is P, and the fourth one are different. And then the two fourth letters will be compared. So compare to, okay, the object is contact. So other first name is gets the first name, other last is the last name. And then if last name dot equals other last, and then you compare first. So if two people have the same last name, such as two people are both Smith last name, and then you compare the first name. Else result is the last dot compare to other last. So if the last name are not equal, then you compare the last name. One is Smith, the second one is, for example, Young, my last name, and then you compare Smith and Young. Getter gets first name, getter gets last name. Okay, so this is the class contact. And then let's see sorting. This is selection sorting. What is selection sorting? The main idea is you select the number and then you put the number to the correct place. You select the smallest number and put the number in the first place. You select the second smallest number, that is the smallest number of leftover, and put it in the second place, like this. So let's go back to see the diagram again. For example, you have the numbers 3, 9, 6, 1, and 2. So first one, you select the smallest number, it is 1, and you put 1 to the first place. And then in the leftover, you select the smallest number. This is the second global smallest number, it is 2. You put 2 to the second place. So there will be two loops. One loop is to loop first number, second number, third number. That is, you find the smallest number, the second smallest number, the third smallest number, and so on. And the second loop is how do you find the number, the smallest number, the second smallest number. This is a program sorting. The program implements the selection sorting. This for loop is to loop the index from 0 to length -1. And for each index, so index is assigned to mean, and then the scan is from index +1 to the last index. This if statement is to compare each number with the temporary smallest number. So the temporary smallest number has the index of, at first the index is mean, and then if the number is smaller, you assign scan. Scan is the current index to mean. So mean saves the index of the smallest number. If the number is smaller, you need to swap the values. You need to swap the current smallest number with the temporary smallest number. So assign next mean to temp, and assign next index to mean, and then assign temp to next index. This is selection sorting. The second one is insertion sorting. Okay. As I said, insertion sorting is to insert the number to the correct place. So use a for. Also, insertion sorting need two loops. One is a for loop. For loop loops the index from 1 to list dot length -1. And then use a while loop to shift the large value to the right. So this is to shift the large value to the right. So this is sorting. And then let's see the program phone list. Phone list is a main program. It has a main method. First one creates the array friends. It has 8 contacts. And then use the constructor 8 times to create 8 contacts. And then call the selection sorting. And then print out the sorting by selection sort. And then use a for loop to print the information of the contact. The insertion sorting is in the sorting program, but we don't use insertion sorting in the main program. If we run the main program, okay, we see the sorted contact by last names. Barney, Gates, Grant, someone to Smith. This is a selection sort. The programs in the PowerPoint are in the editor of Dr. Java. I showed you a moment ago. Insertion sorting. Okay, if you have numbers, and then you pick any item and insert it into the proper place in a sorted sublist, and repeat until all items have been inserted. So this algorithm is like playing cards. You get the cards. For example, you get 5, and then 5 is in. You hold 5, and then if you get a 2, you insert 2 before 5. And if you get a 3, and then you insert 3 between 2 and 5. If you get a 6, you insert 6 after 5. If you get a 4, you insert 4 between 3 and 5. So if you have many numbers, first one you get a 3, and then you insert 3 in the first place. And then 9, you get a 9, and then you insert a 9 right after 3. And then you get a 6, so you switch 9 and 6. That is, you insert 6 to the second position. So if you hold the cards, you get a 3, and then get 9, you get a 6, and then you will shift 9 right to the right of 1 position, and then you insert 6. If you get 1, and then you will insert 1 to the first place, and then you will shift 3, 6, and 9 to the right. If you get 2, and then you insert 2 between 1 and 3, that is, you shift 3, 6, 9 to the right, and then you insert 2. This is insertion sort. This is the programmable insertion sort. So one loop is to loop from index 1 to the last index. The second is for a particular index. We use a while loop to shift the large values to the right. That is, to insert the new value to the correct place. The selection and insertion sort algorithms are similar in efficiency. They both have outer loops that scan all elements, and inner loops that compare the value of the outer loop with almost all values in the list. How do we evaluate the efficiency of an algorithm? We use big O. We use big O something such as big O n squared, like this, to evaluate the efficiency. That is, the complexity. So, for example, big O, big O n, big O log n like this. Selection sorts and insertion sorts both have the complexity of big O n squared. So we therefore say these sorts are of order n squared or of big O n squared. Other sorts are more efficient, such as n times log 2n. The next topic is searching. Searching is a process of finding a target element within a group of items called the searching pool. The target may or may not be in the search pool. If we find the target in the search pool, normally we return the index, otherwise we return -1. We want to perform the search efficiently, minimizing the number of comparisons. So let's look at two classical searching approaches. One is linear search. The second one is binary search. As we did with sorting, we'll implement the searches with polymorphic comparable parameters. First one is linear search. So what is linear search? Linear search is to begin with the first place in a list, and then you compare each value with your keywords. Someone call keywords as a token. If you find the keywords, and then you return the place of the keywords. Otherwise, if you don't find the keywords at the end of the place, you return -1 or return other number as you defined. For example, you have many students, and then you want to find David, and then you compare if the first one is David. If the first student is not David, and then you compare the second student, the third student. This is linear search. The second search is a binary search. For linear search, the elements in the list don't have to be ordered ahead, but for binary search, the items should be ordered ahead. So they need to be sorted before you conduct a binary search. What is a binary search? If you have many elements, first one, you compare your keywords with the middle element. If the middle element is found, then you end your search. If the middle element is less than your keywords, and then you can disregard the first half. You are focused on the second half. If the keyword is less than the middle, and then you can focus on the first half. You can get rid of the second half. So each time you disregard half of the elements. So the algorithm converges very fast. The algorithm has the complexity of log 2n. So this is the idea of binary search. Let's look at the example. If we have the numbers 1, 5, 7, 9, something to 98, they are sorted ahead. If you want to find a number such as 78, so if you use a linear search, you need to compare if 1 equals 78, 1 is not 78, and then you compare 5 if 5 equals 78, and then you compare 9 with 78. You compare 7 with 9, 78. You compare 9 with 78. You compare 12 with 78. This is not efficient. By binary search, the first one, you compare the middle number 45 with 78, because the keyword 78 is bigger than 45, and then you will be focused on the second half. You will get rid of the first half. And then in this half, you compare the middle number 78 with 78, and then you find the number. So binary search is much faster than linear search. This is the explanation of binary search. So each time you compare the middle number with the keyword. If you have two index values, one is start, the second one is end. If the middle is smaller than the keyword, and then you update start from middle plus one. If the middle is bigger than the keyword, you update the end as middle minus one. Okay, let's see the program phone list 2 with searching. So let's go to Dr. Java. Searching. Okay, this is searching, and the method is linear search. Next one, the method is binary search. For linear search, it has two parameters. One is list, second one is target. So index is 0, found is false. It is not found. And while not found, and index less than list.length. If list index dot equal target, then you found it. So assign true to found. Else index plus plus. If found, then return list index. Else return null. So this is the linear search. Second one, binary search. Binary search, you need to assign 0 to mean. Max is list.length, and the middle is 0 at first. Found is false. While not found, the mean is less than or equal to max. Mid is mean plus max divided by 2. If list mid equals target, if the middle number equals target, then found assigned with true. Else if target data compared to list middle is less than 0, that is the keyword is less than the middle number. You update max with the middle minus 1. Else means the keyword is bigger than the middle number, and then mean is mid plus 1. If found, return list mid, otherwise return null. So this is the searching. And then we see phone list 2. Phone list 2, first one, we create the array with all contact. This is the same as the phone list. And then we create the keywords, or we say targets or token. It is Mario Guzman. So this is the test. And then we use linear search to find the test. Later, we use selection sorting to sort the contact, and then we use binary search to find the operation of test. So if you use linear search, you don't have to sort the elements ahead. If you use a binary search, you must sort the elements ahead. Let's run the program. So we found Guzman Mario by both of the two searching algorithms. In this chapter, we learned polymorphism. Polymorphism is associated with inheritance. So you create different objects. You can create the object from the superclass or from the subclass. And then when you call the same methods, so the concrete action is based on where you create the object. So this is polymorphism. The same interface has many different implementations. So I introduced the fundamental concepts of polymorphism. Later in this chapter, I talked about two important algorithms, sorting and searching. You learned the two sorting algorithms and the two searching algorithms. All right, this chapter is finished.